Welcome back, Innovators. So great to have you with us today. This explainer is going to be your absolute ultimate guide to mastering industrial rhythm. And to help us do that, right here with us is our lead innovation catalyst and the chief expert of idea mechanics. You can't miss his signature red shirt, glasses, and that silver accented hair. Today, he's going to help us completely restructure how we think about the heartbeat of our factory floors and industrial operations. We're going to bridge that gap between abstract ideas and practical, everyday execution. Look at our expert right there, adjusting his glasses at his glowing data screen. He's pulling up the very foundation of our methodology today, which is TRIZ. Now, for those of you new to the idea mechanics community, TRIZ stands for the Theory of Inventive Problem Solving. What our catalyst is showing us is exactly how this framework shifts us entirely away from that exhausting, wasteful trial and error approach. We're moving into a mindset of systematic discovery. Because, innovation really isn't just a random eureka spark that only a few lucky people get. It's actually a highly repeatable architectural discipline used to systematically eradicate contradictions. If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next. All right, let's dive right into it. Our catalyst is pointing out some all too familiar flashing red metrics on his workspace right now. I want you to ask yourself, are your precision tools constantly overheating and failing from relentless continuous use? Or, on the flip side, are you just bleeding profit because your assembly line is constantly pausing, waiting for batches and queues to clear up? These are the real-world bottlenecks that absolutely destroy efficiency. Section 1. The Trial and Error Trap. Moving beyond the guessing game. The real shift we need to make here is in our mindset. The old way, kind of the villain of our story here, is where we don't strategically manage the rhythm of our tools. We just apply a continuous, steady strain that causes distortion and overheating. Or we accept massive, wasteful assembly line pauses just because, well, that's how we've always batched our work. But the TRIZ way? The TRIZ way literally treats time itself as an engineering material. We achieve absolute efficiency by mastering two opposing concepts: controlling time and motion by deciding exactly when to pulse an action for extreme precision and when to entirely flow without idle time. Section 2. Harnessing the pulse. TRIZ Principle 19. Periodic action. As our catalyst pulls up the tactical specs onto the lab screens, let's look at Principle 19, periodic action. The core theory here is incredibly powerful. It's all about replacing a continuous steady action with a pulsating or periodic one. When you break a continuous process into discrete repeated pulses, you suddenly gain unprecedented control. You can manage forces that were previously destroying your materials. Our navigator's chart perfectly illustrates this across different industries. Take laser cutting. If you apply a continuous beam, it melts and distorts the edges. It just ruins the material. But the rhythmic solution? A pulsed laser. By delivering the energy in short pulses, those microscopic pauses actually give the material time to cool down. You prevent melting and get a flawless cut. It's an elegant solution derived entirely from changing the rhythm. Let's look at another example and see how this builds. Our expert is calling up the schematics for an in-pipe inspection robot, and honestly, this is like a high-stakes mecha breakdown. If you continuously push a robot through a pipe, friction builds up and it gets stuck. The challenge is real. So engineers used a cam-driven mechanism to create a periodic motion. Step 1, the cam rotates a piecewise curve. Step 2, a large arc expands the robot so it grips the pipe. Step 3, a small arc shrinks the robot so it can move forward effortlessly. This rhythmic expansion and shrinkage completely defeats friction. Section 3, eliminating the pause. TRIZ Principle 20, continuity of useful action. Now, the crucial point in innovation is knowing when to switch tactics. Our catalyst is now guiding us to the exact opposite extreme. We are completely destroying the pause button. Principle 20 is the continuity of useful action. This is basically your ultimate strategic weapon. It means eliminating all unproductive or intermittent actions so the system works at 100% full capacity all the time. Unstoppable, frictionless execution across your entire operation. Just look at that glowing bar chart our catalyst is pointing to. Notice the massive difference in time spent waiting. In traditional manufacturing with a batch and queue system, that first huge spike represents your money wasted on waiting. But when we apply Principle 20, we move to lean continuous flow. We produce items seamlessly, one by one, without any waiting periods. The waiting waste drops to zero. You instantly minimize lead times and absolutely maximize throughput. And this principle scales up to the heaviest industries on the planet. Think about 24/7 operations in chemical processing, power generation, or steel production. For them, starting up and shutting down machinery isn't just a brief pause, it is a massive financial disaster. It avoids wildly expensive shutdown and startup cycles. By running this machinery continuously, it delivers a steady, highly predictable, and profitable output. Section 4. Your perfect operational rhythm, architecting the heartbeat of your factory. We've covered a lot of ground today, and we really want to leave you with this core philosophy. True industrial innovation isn't just about building faster machines, it is about systematically controlling their heartbeat. Whether you're pulsing a laser to achieve microscopic cooling, or you're keeping a steel mill burning 24/7 to eliminate downtime, ultimate agility requires you to master the rhythm of your environment. Innovation is a repeatable process, and you, my friends, are the architects. So, here is our final challenge to you from the Idea Mechanics team. Step onto your factory floors, look closely at your digital workflows, and ask yourself, where are your operations suffering from wasteful pauses? Where are your tools overheating from continuous strain? Where can you introduce a cooling pulse today using Principle 19? Or eliminate a bottleneck entirely using Principle 20? Go out there and start engineering your perfect operational heartbeat right now. Thank you so much for joining us in this explainer, and we will see you next time.